Hi students, this is Alex here. In this video, we are going to find the Fourier series for the given function f of x, which is mod cos x in minus pi less than x less than pi. We are going to rewrite this function. Now f of x is taken as from minus pi less than x less than minus pi by 2 as one part, then minus pi by 2 less than x less than 0 is another part, then 0 less than x less than pi by 2 is the third part, and pi by 2 less than x less than pi is the fourth part. So the given interval from minus pi to pi, that is split into four part, and now minus pi till minus pi by 2 is the third quadrant. So for reference, we take x-axis, y-axis, and this is 0, pi by 2, pi, and this is, if I come in this way, this is also minus pi by 2, and this is also minus pi, if I come in the clockwise direction. So minus pi by 2 till minus pi till minus pi by 2 is the third quadrant. So third quadrant cos is negative. So this is minus cos x here. Then minus pi by 2 till 0 is the fourth quadrant, and cos x is positive in the second part. And this is the first quadrant 0 to pi by 2, which is again positive, and pi by 2 till pi second quadrant, which is negative. So we split into four part. Now let's take minus pi till 0 as a one part and the other one as a second part. Now g1 of x I am going to take, which is minus cos x, and we have cos x. Similarly, g2 of x, the remaining two I am going to take, which is cos x and minus cos x. Now every x is replaced as minus x in g1 of x. So cos of minus is cos x only. So outside minus will be as it is. Then again second part cos of minus x is cos x only. So this is also equal to g2 of x because we have minus cos x and plus cos x. So this is equal to g2 of x. So from this we can understand that this function is an even function. Therefore, that is when g1 of minus x comes g2 of x, we can say f of x is an even function. So f of x is an even function. Since it is an even function, the value of bn is 0. Now it is sufficient to find a0 and an. For finding a0, we have to take 2 by pi integral 0 to pi f of x dx. And now 0 to pi is only these two limit we will be using. So 0 to pi is cos x and pi by 2 till pi is minus cos x. So we are going to further split this into two part. 0 to pi is split into two part. One is 2 by pi integral 0 to pi by 2. That time it is cos x dx, and again 2 by pi integral pi by 2 till pi, and f of x is minus cos x dx. So first part is cos x, second part is minus cos x. Now we are going to integrate this. Integration of cos is sine. So 2 by pi integration of cos is sine. So sine x, and we have the limit from 0 to pi by 2, and this minus sign we can take out, and this integration is once again sine, and limit is from pi by 2 till pi. When I use the upper limit, pi by 2, sin pi by 2 is 1, lower limit is 0. Similarly, sin pi is 0 and sin pi by 2 is 1. Now totally the first term is 2 by pi, second term is also 2 by pi, and this is 4 by pi. So we got a0, which is 4 by pi. So a0 we got. Now an we have to find. So an by formula, an equal to 2 by pi integral 0 to pi f of x into cos nx dx. But this is once again split into two part. 0 to pi by 2, f of x is cos x, then into cos nx dx we have, then plus again 2 by pi integral pi by 2 till pi, and minus cos x we have for f of x into cos nx dx. So the first part is cos x, second part is minus cos x. So for the respective interval, we have substituted. Now always we rearrange this nx, we keep it as a first term. So better, let's rewrite this. That is 2 by pi integral 0 to pi by 2 cos nx into cos x dx minus 2 by pi integral, we have limit now from pi by 2 till pi cos nx into cos x dx. Now we are going to apply the formula. Whenever we have cos x into cos y, it is half cos of x plus y plus cos of x minus y. So this is 2 by pi integral 0 to pi by 2 half cos of n plus 1x. We have to add both the angle plus we have to subtract both the angle, n minus 1x dx. In the same way, for the second term also, we have minus 2 by pi integral pi by 2 till pi half cos n plus 1x plus cos n minus 1x dx. We are going to integrate this. Here we can cancel these 2 and 2 and these 2 and 2. We have 1 by pi. So 1 by pi, and here open bracket, cos integration is sine. So sine n plus 1 x by n plus 1 plus sine n minus 1 x by n minus 1. Then minus this, we will close and put a separate integral, limit 0 to pi by 2. Then minus open bracket, same terms, sine n plus 1 x by n plus 1 plus sine n minus 1 x by n minus 1. And here we have the limit from pi by 2 till pi. Now substituting the upper limit, we get 1 by pi. Now sine of n plus 1 into pi by 2 by n plus 1 plus sine of n minus 1 into pi by 2 by n minus 1. When I put lower limit, everything is 0. Similarly, sine multiples of pi will become 0. So first, when I substitute the upper limit for both of them, it is 0. Minus, bracket open, when I put the lower limit, sine n plus 1 into pi by 2 by n plus 1 plus sine n minus 1 into pi by 2 by n minus 1. So we completed the limit substitution, and finally the first term, and here we have 1 by pi outside, even in the previous step, because 1 by pi is there for both the term. So we can take 1 by pi common throughout. Now we have n plus 1 and there is a minus sign. This minus sign comes here to become plus. So we get 2 times of sine n plus 1 into pi by 2 by n plus 1. Then again there is a minus sign that comes here as minus, but again there is a minus sign outside, so it will become plus. So plus 2 times of sine n minus 1 pi by 2 by n minus 1. We can take 2 common throughout, so it becomes 2 by pi outside. So 2 by pi, we have sine of n plus 1 pi by 2 by n plus 1 plus sine n minus 1 pi by 2 by n minus 1. Now we are going to rearrange this further. 2 by pi, let's multiply pi by 2 inside, so it is n pi by 2 plus pi by 2. by n plus 1. Similarly, this is sine n pi by 2 minus pi by 2 whole divided by n minus 1. Now we are going to take minus sign common and write it here. So this is 2 by pi sine of, we are going to interchange these two. That is, first I am going to write pi by 2, then n pi by 2 by n plus 1. After taking minus sign outside, this becomes sine of minus n pi by 2 plus pi by 2. I am going to write pi by 2 first, then minus n pi by 2. Now, if we see the basic formula, that is sine of 90 plus theta or pi by 2 plus theta becomes cos theta. Similarly, sine of pi by 2 minus theta is also cos theta. So this term is like theta now. We have sine pi by 2 plus theta, then sine pi by 2 minus theta. So we're going to apply the formula 2 by pi cos theta. Theta is n pi by 2 by n plus 1 minus cos n pi by 2 by n plus 1. The common term can be taken outside. So an becomes 2 by pi into cos n pi by 2. This is 1 by n plus 1 minus 1 by, actually one term is minus. This is minus here. Sorry. So this is n minus 1 and even this is n minus 1. So n minus 1 we got. Now we are going to take LCM. So this is 2 cos n pi by 2 by pi. By taking LCM, it is n plus 1 into n minus 1. So n minus 1 minus n minus 1. So we can cancel these two. We left with minus 2. So minus 4 cos n pi by 2 by pi into n square minus 1. This is what we got for an. And this term exists only when n is even. Suppose if n is odd, then what happens is we get cos pi by 2 and cos 3 pi by 2. So odd multiples of cos pi by 2 are 0. So the value of an is 0 when n is odd. So we have only, this term exists only for when n is even. And here definitely n is not equal to 1. So we have to find a1 separately, since there is a denominator n square minus 1, and when n is 1 here, denominator becomes 0 and an does not exist. So this is applicable when n is not equal to 1. So for that purpose, we have to find a1 separately, which is 2 by pi integral 0 to pi f of x with f of x into cos nx, but n is 1, so cos x dx. So this we are going to split into two parts as usual. 2 by pi integral 0 to pi. It is cos x when it is from 0 to pi by 2, and into cos x is already there. I am just replacing only the f of x. Then plus 2 by pi integral pi by 2 till pi, and this time function is minus cos x into cos x dx. So this is 2 by pi integral 0 to pi by 2 cos square x dx minus 2 by pi integral pi by 2 till pi cos square, actually minus is taken out, so cos square x dx. Now we are going to simplify further. Integration of cos square, we are going to apply the basic trigonometric formula, then we are going to integrate. We have 0 to pi by 2. This is 1 plus cos 2x by 2. Without applying this formula, it is not possible to integrate. So we can cancel these two. Then 2 by pi integral pi by 2 till pi 1 plus cos 2x by 2 dx. Even we can cancel these two also. The basic formula is, whenever we have sine square x, it is 1 minus cos 2x by 2, and whenever we have cos square x, it is 1 plus cos 2x by 2. So we will apply this formula. So after applying that, we are going to integrate. One integration is x, cos is sine. So sine 2x by 2 and 0 to pi by 2 minus 1 by pi, and again this is x plus sine 2x by 2 and pi by 2 till pi. We are going to apply the upper limit. So this is 1 by pi by 2 plus, when I put pi by 2 here, it becomes sine pi, which is 0. So second number is 0. When I apply the lower limit, everything is 0. Minus 1 by pi. When I put pi, sine 2 pi is 0. And when I put the lower limit, minus pi by 2. And here when I put pi by 2, after cancelling 2 to sine pi is 0 again. So plus 0. So totally this is 1 by pi into pi by 2 minus 1 by pi, and here pi minus pi by 2 is pi by 2 after taking LCM. So we can cancel this. This is 1 by 2, this is 1 by 2. 1 by 2 minus 1 by 2, which is 0. So A1 is 0. Now we will substitute this in the Fourier series expansion. So f of x is a0 by 2 plus summation n is equal to 1 to infinity an cos nx plus summation n is equal to 1 to infinity bn sin nx. Now a0 by 2, a0 we got it as 4 by pi. And when I substitute here, 4 by pi by 2 will become 2 by pi. Then, so 4 by pi by 2 will become 2 by pi. Then a1 is 0 anyway. So 0 into cos x, anyway it is going to be 0. Now summation starts from n is equal to 2 till infinity an, and an also we see here it exists only when n is even. So we have to write n is even, then minus 4 cos n pi by 2 by pi into n square minus 1. So let's write it here, and instead of 2 we have to say it is even, and it is minus 4 cos n pi by 2 by pi into n square minus 1 into, we have cos nx, and since bn is 0, the last term is completely 0. Now f of x becomes 2 by pi minus 4 by pi can be taken outside. Summation starts from n is even till infinity, and it is cos n pi by 2 by n square minus 1 into cos nx. Now this even can be replaced as 1 to infinity by changing n as 2n, because 2n is even. So I'm going to replace it here. So this becomes 2 by pi minus 4 by pi summation n equal to 1 till infinity cos 2n into pi by 2 by 2n whole square minus 1 into cos 2nx. Now we can cancel these two, and cos n pi becomes minus 1 whole power n. So finally f of x becomes 2 by pi minus 4 by pi summation n is equal to 1 till infinity minus 1 whole power n by, and this is 4n square minus 1. If we want, we can write it as 2n minus 1 into 2n plus 1 also, or 4n square minus 1 into cos 2nx. This is the required Fourier series expansion for the given function.